what I want to show you here are inverse functions. Okay, you got to remember that inverse functions is effectively, this is a function. I said what's its inverse? You would basically swap the x's and the y's. Okay, and that's basically what determines the inverse. It's a reflection over the line y equals x. If I plotted 1 comma 2, 3 comma 4, and 5 comma 6, and then I went ahead and plotted 2 comma 1, 4 comma 3, 6 comma 5, and here's my line y equals x. This point and this point, these are all reflections over this line. Okay, so that's what an inverse is. If I give you a function y equals 2x plus 5, and I said, what's its inverse? You're going to swap x and y. So there's a y would make an x. That's what the x would make it a y. Okay, and at that point, you just need to do algebra and solve for y equals. So to solve for y equals, we'll subtract 5 from both sides and divide by 2. This function has this inverse. Okay? There's a way to prove whether two functions are inverses of each other. Okay, so let me give you another example. If I said y equals 3x minus 7, okay, let me find the inverse and I'll show you what I mean. I'm going to just quickly find the inverse to that function. Find it, we're switching the x's and the y's. We got 3y equals x plus 7, so y equals x plus 7 over 3. But let's assume the problem was this. Here's function 1, and I said function 2 was this. And I said prove whether these two functions are inverses of each other. There's two ways you can do that. One is you could just take this first one, do what I did over here, and see if what you get matches the second function. If it does, then they're inverses. Okay, it's basically doing what we did here and just checking to see that the inverse matched. But there's another way to do it using composites. And basically, it looks like this. If you have two functions, we'll call it f of x and g of x. So let's go back to this problem. Let's call this f of x, and we'll call this g of x. Okay, if f of g of x equals x and g of f of x equals x, then you could say these two functions are composites. So let's check that. Here's f of x. We said f of x equals 3x minus 7, and we said g of x equals x plus 7 over 3, and we're checking to see if they're inverses of each other. So f of g of x means I'll take 3x, instead of x I'll put in g of x, and I'll simplify that, and I'll get x plus 7 minus 7 equals x. And sure enough, f of g of x equals x. Now let me do g of f of x. When I do g of f of x, I get, instead of x, I'll put 3x minus 7 plus 7 over 3 equals 3x over 3 equals x. So both f of g of x and g of f of x equals x. So when that happens, you have proven that in fact these two functions are inverses of each other. On a quiz or a test, if I ask you to prove inverses and I don't tell you which way to do it, you can do it this way. Just given these two functions, find the inverse of this and see if it equals that. But if I say use composites, then I want you to run this test. And both of these have to be true. If this one is x and this one isn't x, they're not inverses of each other. Good luck.